So in this video, I'm going to be talking about claims. I'm going to be talking about three kinds of claims that scientists make based on scientific research. Now, by a claim, I mean a conclusion that somebody draws that they say is true or valid. These claims that I'm going to talk about, they aren't exhaustive. They aren't all the kinds of claims that scientists might make or that other people might make drawing on science, but they're three important ones, so I'm going to go through them. The first kind of claim is what your book calls frequency claims. Frequency claims are claims that involve one variable and they express rate or degree. Now, as an aside, I don't love this term because frequency usually means count, and frequency claims can refer to something that's a count of discrete values or a measurement of a continuous value. So like how much did it rain last year in Eugene would be what your book would call a frequency claim, even though it's a continuous measure. But this is the term that your book uses, so I'm going to stick with it for this course. Another term for this might be a univariate claim, but that sounds a little obscure, so we'll go with frequency for now. Okay, here are a couple examples of frequency claims. One might be an epidemiology study of incidence and prevalence of something. So for example, we might ask, how many people have a serious mental illness? And the answer to this would be a univariate claim. Everybody, half of all people, 1% of people. Those would be different claims. Some of those might be valid, some of them might be not. Another kind of frequency claim, an example of one would be from a public opinion survey. A pollster might ask, how many Americans approve of the job that Congress is doing? And so the claim, oh, most people approve of Congress, that would be a frequency claim. Now, in case you're curious, this isn't going to be on the quiz or anything like that, but since I brought them up, I thought I'd give you the answers to both of these. So if we ask how many people have a serious mental illness, well, according to the National Alliance on Mental Illness, approximately 1 in 5 adults in the United States experiences mental illness in a given year, and approximately 1 in 25 adults experiences a serious mental illness in a given year that's serious enough to interfere with or limit one or more major life activities like family or work. So mental illness is not at all rare, and it's something that by doing surveys, by studying representative samples, asking people what kinds of experiences and symptoms they've had, public health researchers can try to estimate. The other claim I mentioned, most people approve of Congress, well, turns out that's not true. Right now, the latest version of the Gallup poll, as of about a month before I'm recording this video, was that approximately 22% of people surveyed approve of the job that Congress is doing, 74% disapprove, 5% have no opinion. And in case you're curious, this is historically not that anomalous. Americans tend to just not approve of Congress most of the time. You see that one exception or after September 11th, 2001. But other than that, most of the time, a majority of Americans don't approve of Congress. Kind of interesting. Okay, so that's a frequency claim. The second kind of claim I want to talk about is an association claim. Association claims involve two or sometimes more measured variables, and they assert that the value of one variable varies systematically with the value of another variable. So an example of that might be men are taller than women. So one variable would be the sex of people, men, women. Another variable would be height. And so we're making a claim that sex is associated with height. Another example of an association claim might be people who are assertive are also talkative. So one variable is how assertive somebody is, a little or a lot. Another variable is how talkative they are, a little or a lot. And so both of these would be examples of association claims. They're claiming that there's some kind of a statistical relationship between two variables. So there are different kinds of associations that can be implicated in an association claim. Here's an example of one hypothetical association, but maybe a realistic one. Association between people's exam scores on the x-axis, so going from left to right, we have exam scores from low to high, and their happiness ratings after they get their score on the y-axis going from 1 to 5. Let's say this is a 1 to 5 scale. And so what you see here is that as exam scores go up, happiness ratings go up. So we'd say this is a positive association. Now this is a hypothetical example. Let's say number of rainy days in a month and people's happiness rating over the course of that month. So here in this hypothetical example, the more it rains, the less happy that people report being. By the way, there's some empirical research that a former student of mine did that shows that even though a lot of people think this is true, it actually isn't, which is kind of interesting. So this would be a claim about a negative association. This is made up data. In fact, there doesn't seem to be that much of an association. Sometimes the relationship between two variables is what's called curvilinear. That means that it doesn't just go in one direction. So here we might be measuring among different people, how many hours did you sleep last night? And then the next morning we ask them how happy they are. And we might see a curvilinear relationship where somebody who got no sleep is really unhappy. Somebody who slept 20 hours is really unhappy. But people who got sort of a middle amount, 8 to 10 hours, they're pretty happy. So this is called a curvilinear relationship. And then we might have just a zero or null relationship. So we might just ask people every day for a week how happy you are, and as the week goes on, there might not be any difference, so this would be a zero relationship. So these are different kinds of association relationships that we could talk about: positive, negative, curvilinear, zero. Okay, the third kind of claim I want to talk about is causal claims. Causal claims involve two or more variables, and they go beyond an association. An association just says there's a relationship there, a statistical or a pattern relationship. With a causal claim, we're going beyond that, and we're asserting that one variable is actually responsible for changing another variable. So an example of that might be smoking causes lung cancer, or using your smartphone too much makes you depressed. These would be causal claims. Someone is saying that one variable, like whether or not you smoke, is responsible for another variable, like whether or not you develop lung cancer. Now, in order to decide whether a causal claim is valid or not, there are three criteria that we typically look at to see in the evidence that someone's presenting, are these true? And if all three of these are true at the same time, then we can safely infer that a causal claim is supported by the data. But it has to be all three at the same time. It can't be showing them in different studies. It can't be just showing one or two of them. So we would infer that an event X is a cause of an event Y if all three of these things are true. One is that in our data, there's an association between X and Y. The second is that the event X happened before the event Y. And the third is that we can eliminate other possible causes that may be confounded with X. This is what your book calls internal validity. I'm going to quibble with that in a moment. This is also sometimes called isolation. So let's take the smoking and lung cancer example. So let's say we have a data set of health records. So we would ask first, is whether you're a smoker and whether you developed lung cancer, is there an association with those? So if the smokers were more likely to develop lung cancer, then we'd say, yep, that's supported. The second one, did smoking happen before lung cancer? If that was true in our data set, that people started smoking before they acquired lung cancer, we'd say, yep, that's supported. And then can we eliminate other possible causes that may be confounded with? So other things that might have led people both to start smoking and to acquire lung cancer. If we can rule out that some other, these are sometimes called third variables, account for this association, then we would have all three of these checked off and we would say, yes, this data provides support for the idea that smoking causes lung cancer. Now, I mentioned a moment ago that I wanted to quibble a little bit with the term internal validity. This is the way your book uses it. This idea of internal validity actually comes from a book that was written back in the 1950s. And they use the term internal validity a little bit differently. So I'm just going to quibble a little bit. Most experts who study research methods use the term internal validity for all three of these things. They'd say if a study meets all three of these criteria that I just showed you, it has internal validity. Your book uses internal validity just for the third criterion. That's why I said sometimes people call it isolation because they reserve the term internal validity for all three. Sometimes your book uses it the other way too, so this is a little bit confusing. In this course, I will try to be clear what I'm talking about when I use the term internal validity so you know what I'm saying. Now, when you see somebody making a claim in the news, in a study, in a press release, something like that, there are some different kinds of words that people use to refer to what kind of claim they're making. And in particular, people often will mix up association claims or causal claims. So, for example, people might say that being assertive is linked to being talkative. This is not going so far as to say cause and effect. This is just saying there's some relationship there. They might say is associated with, is correlated with, etc. These would be terms that people would use to make an association claim. If somebody said being assertive causes you to be talkative, then that's a causal claim. They may say it exacerbates, or it changes, or it leads to. These are words that imply causality. And so when you see a claim, and I'll be very honest, sometimes it's not entirely clear. And sometimes people, all they can support is an association claim, but they want to make people think that they have support for causation, so they use some kind of ambiguous words. You want to be on the lookout for that when you're evaluating claims. And if it sounds like somebody's trying to imply causality, you want to hold them to that higher standard. Because remember, association is just one of the three criteria people have to provide support for to support a causal claim. And so if somebody's implying causation, you have to look for those other two criteria as well. Okay, that wraps up this video on the three kinds of claims. Don't forget to do the concept check questions, and I'll see you next time.